This is a video tutorial for installing OpenIPC on the MC-L12B IP camera. This camera uses the SigmaStar SSC30KQ system on a chip and a Sony IMX335 image sensor. Although the SSC30KQ chip is not quite as good as the SSC338Q, it is the second best option and the camera is much cheaper, which is why I chose it. So your camera has arrived. Now what? The first step is to locate the diagnostic UART pads. They are quite small and depending on the particular unit, the heatsink might obstruct them more or less. You will need to solder wires to both pads. A soldering iron with a finer tip will make it easier. Now you'll need to connect the camera to a USB to serial converter. I have this plug from an old LiPo lying around, so I will use that, but you can always just solder the wires directly to the converter. Apart from soldering the TX and RX lines, you also need to connect the ground to make this work. You should probably insulate the connectors in case they touch each other. You will also need this sort of cable for powering the camera and connecting it to your router via Ethernet, and a power supply with a barrel connector that can provide between 5 and 12 volts. You can usually buy this sort of cable together with the camera, but if not, you can also buy these separately. But be sure to check the polarity on your power supply to avoid frying the camera. Once you are ready, you can plug the converter into your computer. Go to Control Panel and Device Manager to see if it is detected. It should be detected as a COM port device, in my case COM14. Remember the COM number assigned to your device, you will need it later. If your device is not recognized, you can try to search the name of the main chip on your unit to find and install its drivers. Once that's done, you will need to install a piece of software called PuTTY if you don't have it already. This is for communicating with the camera via UART. You will also need to install a TFTP server for flashing the firmware on the camera. I use the one from SolarWinds because it's simple to use. You might need to input your details. Let's open PuTTY. You will want to set it to serial connection 115200 baud rate and the COM number of your USB to serial converter given by Device Manager. When you are ready, click Open and a window will pop up. You can now power on the camera. If everything is working properly, you should see some text printed inside the window. This is the camera showing the progress of booting its operating system. If you don't see any text, check if your UART TX and RX lines are connected the right way round. Now go to the OpenIPC website and find the supported hardware tab. Find the SSC30KQ chipset and click on the link. Here you can generate a random MAC number and select the following options. My camera has 16 MB of flash, so I choose this value. I want to use this camera on a drone, so I choose the FPV option. You might also want to try Ruby though, it's a different firmware also designed for FPV. Click on Generate Installation Guide. This page gives you some instructions, but I found that for this specific camera they don't work. You can download the firmware from here. You will need to place this firmware file into the directory of your TFTP server. For me, it's simply found under C drive, but I believe you can change it in the settings of your TFTP server software. Now open both PuTTY and the TFTP server. You will need to check the IP address allocated to your TFTP server. It might also be helpful to log into your home router to check which IP addresses are already taken by devices connected to it. Now go to the PuTTY window and plug in your camera, this time spamming the Enter key to interrupt its boot sequence. You should now have access to the bootloader console. From here, you should set the IP address of the camera to a valid address for your home network. This usually means the third part of the IP address should be the same as that of your computer, and this address should be different from the devices already connected to your router. You also need to set the server IP to the IP address of your TFTP server. Now run this command. It should make the camera send a copy of its original firmware to your TFTP server in case you ever need it. You can right-click to copy a command to the terminal window and press Enter. Here we see that it is not actually working. If you see the same thing as here, it means you need to disable your firewall for this. Press Ctrl+C to abort the operation and go to Windows Security to disable the firewall. Just make sure to re-enable it later. If you try to run the same command now, it should work. Wait for it to finish. You should now see a new binary file in your TFTP server directory. This is the backup of your camera's factory firmware. You can now run the next command, which will load the OpenIPC firmware from your TFTP server to your camera's RAM. Next, run this line, which will erase your camera's flash memory and write the OpenIPC firmware to it from RAM. Wait for it to finish. Now run the command reset. This should reboot the camera. My camera got stuck here. If this happens to you, you can unplug and replug it. If everything went well, the camera should now boot into OpenIPC. You can log into the OpenIPC terminal with the default username root and password 12345. Congratulations! Your camera runs OpenIPC now. You can now connect to your camera's terminal through your network using SSH, without needing the USB to serial converter. I hope you found this video useful. Thank you for watching.